mean, at least you guys can see that I'm not just sitting around watching anime for the last couple of months. Actually, I'm kind of lying. I've been so demotivated. All I've been doing is sitting around watching anime for the last couple of months. I should put this one aside, because I don't want to wreck that. Bloody hell. I'm supposed to be fixing this and testing it for a friend, which I will do. My ADHD is just fucking horrendous. Oh, I don't want to spill that on my face. So anyway, what am I doing today? So, something fascinating came to me. See, over the last few months, actually, over the last few years, our weather's been getting a lot worse, like dramatically worse here. So say what you will, I'm not going to get into the whole he said, she said, or who's right, who's wrong fucking climate thing. But I think most of you guys know, me being an ecologist and amateur meteorologist, that the stance that I take on climate change. So anyway, what I have downstairs, because the power has been failing a lot more in the past few years, is we've got our mains panel like this, and then I've got a sub panel like so. And right now, here's my Renogy. Not sponsored by Renogy yet. Inverter charger. Right now the power comes in like so, and then from here it goes out like this, and then I've got my batteries down here. I've got lots of batteries that go into my Renogy. The idea here is that as long as mains is active, the power goes into my inverter like so, and some of the power goes down here when the batteries are dead. Obviously they're floating, because as long as the batteries are fully charged, they're not really doing much. But then the power goes this way. It goes out to here. So now if mains fails, then that's gone, and then this changes direction. It goes like this. So my battery bank starts feeding my inverter, which in turn keeps my lights, fridge, furnace, office, and internet running. Now, you can't do this with just any inverter, because with some of the equipment that we have here, like our furnace, for example, needs extremely pure sine wave energy. This inverter is a fairly expensive one, and it, in fact, is a pure sine wave inverter, not a modified or stepped sine wave inverter, okay? Now, I'm getting to the point. So this is able to run everything that I need to, and I can run for approximately about 24 hours solid off my battery bank. If the furnace isn't running, I can run for as much as 36 hours plus, okay? So now, here's the problem, though. When the power goes out for multiple days, which I live in a city and it does that sometimes because, you know, bad weather, I need to hook up my generator. So when this is the case, let's draw the same diagram here. When this is the case, mains is no good. And then what do I have to do? I have to actually run a generator outside to power, or to charge my batteries. So then what ends up happening is, and this is kind of clever, I think, that's my opinion, is that I pull out the generator first thing in the morning, hook it up to the inverter, and this will charge my batteries, okay? So the idea is that if I throw that generator, and this is practice because I lost power for 8 days last year, okay? If I charge up my inverter using my generator, it takes roughly about 7 hours to charge up my battery bank to full at about 50 amps off of this generator, okay? So, but the catch is that it becomes a bit of a pain in the ass because I actually have to disconnect the cable from the breaker box like this, and then I have to hook up a cable that goes outside. That's not very cool, and I really don't want to do that. Because realistically that should be done by a proper electrician, which, by the way, I should actually be a journeyman, except I dropped out of the trade because humans are fucking gross. Okay? Yeah, I love being picked on, as you can tell. It's actually caused a lot of trauma to me. So anyway, what I've done is, because I am an unofficial electrical engineer. I know things about this thing. Yeah, these are really common in the UK as well. I intend to use this as a manual transfer switch rather than a proper or I shouldn't say proper, rather than an automatic transfer switch. But what is this cool little thing? Well, what this cool little thing will allow me to do, and I'll show you in a diagram here, is we've got our mains panel here, we've got our secondary panel here, we've got our inverter here, okay? Now, we have our generator outside. This goes up to here, sub panel. Inverter / charger. Okay, so what this little guy right here does, and I can't honestly remember the drawing, it's basically a contactor. It's a contactor, essentially. This is a contactor. So anyway, what the idea here is that we will have a transfer switch. Okay, so the gen set comes into one side, mains comes into the other. Now, what I can do with this thing is I can manually transfer from one load to another, or one line to another. That's the idea of this thing. So what'll happen is that when the power fails, when mains fails, this transfer switch, let's see here. So this is mains right here. So this is, when it's on mains, okay, there's actually like a motor and a spring inside of here, okay? So the motor remains active as long as mains is active when I set this thing for auto, right? It'll charge. It'll actually, it's a kinetic mechanism, so it'll kinetically charge a spring and a motor. So then if the motor fails, or if the mains fails, this power here is not present, what it will actually do is this will, check this out, watch the breakers here. This has an interlock in it to make sure that both sources cannot be active at the same time, okay? So the idea here is that as soon as mains fails, it will instead connect the generator plug outside to my inverter, disconnecting the mains panel, which means that I don't have to actually switch over my my leads over to an external cable if the power's out for a long period of time. So this obviously really does make my life 20 times easier. It does have to actually be in a proper enclosure, and I will have to have a proper electrician install this. But last year when I had to take measures into my own hands, it was because we were out of electricity for 8 days. So anyway, this is going to be kind of cool, because now what I can do is I'll have a generator cord outside, and if the power is out for long enough that my batteries are nearly depleted, I can simply go outside and know that this thing is in this position and that my generator will now charge the battery bank. And of course, as soon as mains reactivates, we'll switch back over to the main breaker, and that will ensure that mains is charging the battery bank and the generator is disconnected. So now that I've explained the whole mechanism and theory and principles here, let's take a look at this little thing. So this little guy here, I actually got it from Amazon. Okay. We'll let my electrician determine the legality and safety certifications of this thing. Because I'm pretty sure that it said right on there that it's UL and CSA, otherwise I wouldn't own it. It has to. Even though it's got Chinese all over it, I mean, it's still UL. So this has a beautiful little Phoenix connector on it for supervisory. So that can let me know if mains has failed, of course, or, you know, what it's running on. But it's also got some little LEDs here that will tell you your sources are active. So yeah, taking this thing apart now, let's see how this little thing works. So here's your motor, okay? And we'll take off the protective housings on here, because these are actually a really clever mechanism. And the really neat thing is that if I really wanted to, I could take off the breakers that it came with, and I could replace them with ABB or Eaton or something which is a little bit more well known, right? So this is essentially what's called a mechanical interlock. All right, so what we've got here is, oh, can I take the top off as well? I want to. Can I take this? Will you let me take it off, huh? I want to take you to bits. I'll bet that this handle has to come off first, and there's probably some screws. Let's try that. So this is a mechanical interlock. What is it a mechanical interlock do, you might ask? I don't think I can get this off. So what this thing does is it makes sure that both sources cannot be active at the same time. Hence why there is a cover on here. It's because there's two breakers in here. Now, theoretically, I could actually just, pop on a set of ABB breakers if I really wanted to. I don't think I've heard of CHRE. Some of you might have. But anyway, like I was demonstrating earlier, so if this is on mains right now, if I'm just doing this manually, the motor's not active, then what this does is this turns off source 1, being mains, and it activates source 2. So the whole purpose of this is to make bloody well sure that you don't backfeed and blow shit up. Because otherwise what will happen is you will blow the generator's breaker, or you could do something dangerous for a momentary second. Let's say that the entire grid on your street level grid has been deactivated, disconnected from the main feeder grid, right? And so, you got your generator hooked up to it, and just by chance, it backfeeds into the lines. Transformers work in two directions, right? Now, of course, your little 3,500 watt generator does not have enough power to go into that microgrid. What will actually happen is it'll trip the breaker because it's an overload, right? But let's just say by chance that you're running, say, I don't know. By the way, this is only rated for 30 amps. Let's say by chance you were running like a massive honking fucking generator at home, right? You could potentially backfeed, and that will actually backfeed into the transformer that feeds your house, and you could dump, I don't know, 8K, 14K, 24K, 48K back into the grid, and some poor electrician could get fucking fried. And so that's where mechanical interlocks like this are very, very, very important. Is because it'll make sure that only one source can be active at a time. Now, the idea of this guy right here with the motor aspect of it is that you guys have probably seen Jurassic Park where he pumps the handle. That's real, by the way. You've got to like pump to charge the spring that then closes the contacts on the massive giant disconnect, okay? This kind of works in the same way. So the principal concept here is just that when this thing has electricity, this little motor will energize, right? And it'll go like this. It'll go, here, let's put it back in the remote, okay? Power comes on. It'll go over this way. Then the spring will sit there and basically engage. So when you lose mains, it'll just pull it back this way naturally, and it will enable source 2. Simple as that. At least that's what I'm assuming, because I can't get the mechanism open. Now, if that's not the case, I would assume that step 2 would be that if mains fails, this would be like a an if gate function, I believe. It'd be if? It'd be or. Yeah, sorry, it'd be or. So if you've got mains here, that would mean that the switch would go this way. So if mains is present here, and we don't have source here, it'll rest in this position. And I'm assuming that it'll stay there because this will be the dominant feeder right here on these guys right here. So then I'm assuming that once this one fails, it will allow for this one here to energize the motor and turn it back in the opposite direction. Pardon me one second, my chamomile meal's ready. Alright, by the way, a little tip for any of you boys, girls, and or other. If you've got bad anxiety, by the way, you can actually drink chamomile tea and it will help bring you down. I'm fucking dying right now. So anyway, that's basically what I wanted to show you guys, is that this is a little manual / automatic transfer switch that you can get off of Amazon. These are really common in the UK. In fact, one of my favorite YouTubers, that would be Photonic Induction. Andy! He's back, by the way, sort of. But he actually did a demonstration with one of these guys many moons ago. Demonstrating, he installed one of these in his home. It's almost identical in functionality for the same reasons why I'm installing one, or having one installed, I should say, is because, he's a electrical genius and needed backup power. So there you go. Now, as far as the wiring diagram goes for this guy, it's actually pretty straightforward. Do I have another piece of paper available? I think I do. So with this guy here, because it's such a simple concept, and by the way, according to North American electrical code, this has to be inside of an enclosure. So what'll actually have to happen is, I'm assuming when my electrician goes to install this, is that these covers are going to have to come off. And then this is going to have to go into a 4x4 box with a plate with a cutout in it for this right here. So that'll ensure that only this is exposed and the rest of this is sealed inside of the enclosure, because you can't have those junction points, you can't have those terminals exposed. Even though, you know, the wires are probably going to be trimmed short and properly installed inside of these things, you have to ensure that it's all enclosed, self-contained inside of an enclosure. So anyway, let me show you how this thing hooks up now. So we have this transfer switch like so. Like so, okay? So we've got 1, 2, what is it? Nope, 1, 3, sorry. 1, 3, 1, 3, and 2, 4. This is just, I'm going by what they've labeled on here. These are basically double pole, double pole, single throw breakers. Yeah. So this would be means. This would be gen. But then here's the thing. So you've got your lines coming out here, right? So we're going to have our line and neutral. Line, neutral. So the way that these guys actually have to connect is they actually have to go out like this. So that's how that has to be connected. And then you've got your load, or line, neutral, sorry, the L stands for many things. English is a complicated network, language. So line, neutral, line, neutral. That's essentially how this has to hook up. And the reason why you have to break both is just in case you get a floating neutral and it comes across on the ground, because everything has to be a common ground through the whole system. And you don't want to have backfeeding voltage, which could pop something or damage things. So you have to make sure when you're using a transfer switch that you are lifting the neutral. In my case here, because I'm only switching 120 volts and not 240, I only need 2 poles. Otherwise, I would actually need a 3-pole breaker configuration to be able to run this, because you would have, in 3, you would have this. L1, L2, and neutral, like so. So that would be a proper 120/240 configuration. In this case here, you've got like so would be 120, and then this one here, so 120. But then if you take these two here and put them together, you get 240, and that is the North American split phase system, by the way. So that's, again, you know, I'm only running 120, so I've got line and neutral. Not line 1, line 2, just line, neutral. So I think I've beaten that fucking dead horse. So I hope that that makes sense to you guys, and that was entertaining at the very least. So anyway, I'm going to drink my chamomile tea because it feels my fucking heart's going to explode. You know what? I drank coffee this morning because I was tired, and then I took some pre-workout before the gym. Jesus Christ, do I regret that. So anyway, thanks for watching and tolerating my insanity. I hope that was entertaining. Don't forget to like and subscribe. Tell your friends. And in fact, if you want to help feed me, you can join the Patreon. Thanks, guys. Ciao.